Dear students, have a nice day. In this video lecture, we are going to discuss about random access methods. This is Unit 3 topic. Already we have discussed about data link layer, how two sublayers. One is link layer control protocols and layers. Another one is medium access control layer. In this, how we can access the medium. For that, access control. For that, we need a random access method. We are going to discuss about the random access method in this video. So this random access method is week 8 lecture 1 CDT 22 topic, okay, in unit 3. So before starting our topic, we have the regular practice. We must be know what is the outcome of our lecture. After completion of this lecture, students will be able to identify the transmission time while using random access protocols. Different random access method is there. While using those methods, what is the transmission time? Any delay is there? How much time it is taken? A bit will receive from source to destination. That we are able to discuss in this video lecture. What is medium access control? We can consider the data link layer as two sublayers already we discussed. Okay, upper sublayer, lower sublayer. Upper sublayer is the data link control layer, lower sublayer is medium access control layer. Okay. So if the channel is dedicated, we do not need the lower sublayers. Dedicated link is there. One node, that means a source to destination, separate medium is there, means we don't want this access control because it will be allocated for them. They will share the data at any time. No need to share the medium to others. Okay. So these two layers already we know, logical link control layer and media access control layer. When node or session are connected and use a common link called a multipoint or broadcast link. What we are saying that, so in case we know that multipoint connection, okay. So the wire is there, the many systems will share this medium, okay. So how this medium will used by these systems? So for that we need access control, okay. So multiple access protocol for coordinate access to the link. The problem of controlling the access to the medium is similar to the rule of speak in an assembly. We know that how assembly is going on. So the people are talking, overlapping. There is no protocol is there. Anybody can talk anything. Like that it is going. No one will understand. Okay. The procedure guarantee that the right to speak is upheld and ensure that two people do not speak at the same time. Do not interrupt each other. Do not monopolize the discussion and so on. Like that, we will give many rules. Because if anyone is talking, others are listening, no, everybody should understand that. For that purpose, we will give rules. Okay, that is protocol. Same thing we are going to discuss here. The situation is similar for multipoint networks. Multiple systems are using the same medium. There is no rules, means everybody can access, then data may be disturbed, may be lost. For that, we need some protocol. For those protocols will be categorized according to their usage. So this is the classifications. So many multiple access protocols are there. So based on the type and access, that is classified into three categories. One is random access protocol, another one is controlled access protocol, and channelization protocol. In our syllabus, we have random access protocol and channelization protocol. So we are deeply discuss about random access protocol and channelization protocols. So in this particular video, we are going to discuss about random access protocol. Okay. What is random access? Random access or contention method. Okay. So we can have another name also, contention method. That means no session is a superior to another session. Okay. So in this particular multipoint access control, there is no one will act as a superior to another session, and none is assigned the control over another. We are not given any control to any system for other systems. Okay, to manage other systems. No session permits or does not permit another session to send. Okay, so all the sessions have the same rights. No one have prior. That is a superior. Okay, at each instance, session that has data to send use a procedure defined by the protocol to make a decision on whether or not to send. Okay, so protocol will decide the session will send or not. Okay, individual session have no rights. Protocol only decide. Okay, the decision depends on the state of the medium. Okay, so we are using that medium. So the medium is free or occupied or busy according to that states. Sorry. According to that states, it will be work. Okay. Each session can transmit when it decides on the condition that it follow the predefined procedure. Okay. So what is that? Predefined procedure, including the testing of the state of the medium. Two features give this method its name. Okay. So first one, there is no scheduled time. There is no scheduled time for a session to transmit. Transmission is random among the sessions. Okay, that's why we are saying random access. Random access means transmission is random among the sessions. That's why these methods are called random access method. And second one, no rules specify which session should send next. Okay, there is no rules for define that next. This session will be next. The next session will be next, like that. There is no rules. Session compete with one another to access the medium. Okay, so there is no rule. You will first you will send, second you will send, third you will send, like that. Everybody will compete. Okay, but who will get the access? According to the protocol, it will be decided. Okay, that's why we can say contention method. So we can say this method is random access or contention method. In the random access method, each session has the rights to the medium without being controlled by any other session. Okay, in random access, if all the sessions is try to send the data at the same time. Okay. However, if more than one session tries to send, there is an access conflict collision. Okay, access conflict, that means collision, and the frames will be either destroyed or modified. Okay, so send here, this is the medium. So one person is trying to send, another person also trying to send the same data. So what happened? He also sends some data, he also sends some data, it will be overlapping and data may be destroyed or modified. Okay, so to avoid these access conflict or resolve it when it's happened, Each session follows a procedure that answers the following questions. When can the session access the medium? What can the session do if the medium is busy? How can the session determine the success or failure of the transmission? What can the session do if there is an access conflict? When it will access? When the medium is busy or not? If busy, what it will do? If access conflict happen, what it will do? The data is transmitted successfully or not? So these are the questions is there. For that, you are answered. That is a solution for this. So for this, we have different protocols. The first protocol is Aloha. Okay, Aloha is the first random access protocol. It's the simplest protocol. The earliest random access method was developed at the University of Hawaii in early 1970. It was designed for a radio LAN, but it can be used on any shared medium. Okay, initially it is designed for radio LAN, but it may be used for shared medium. So I already said the medium is there. If somebody are sharing, so they can apply this rule, this protocol. It is obvious that there are potential collision in these arrangements. So we know that collision may be occurred. Okay, the medium is shared between the sessions. When the session sends the data, another session may attempt to try at the same time. Okay, if data from the two sessions collides and become garbled. Garbled means it's maybe destroyed. See this diagram. Here session 1, 2, 3, 4 is there. Okay. So all the sessions are transmit the frames. Okay. There is no time limit. It is a common medium. So you see here this particular time. Okay. The first frame when it is transmitted, there is no collision. Okay. There is no collision. But what happened? The next frame is there, no? You see here. This frame is reached this place, this time. So when it will be there, you just consider here. Okay. So you can consider there. This particular line here, collisions may be there. What happened in the medium? This is the common medium. So this entire medium, okay, this entire medium using 4 sessions. Okay. So this is the medium. We know that. So from this medium, how the frames will be collide. Okay. So when you are taking this particular time, there is no frames are sent by other sessions. Session 1 only have sending the data. There is no collision. Okay. But when we are compared with the second frame, okay, so see here, this frame, it will be sending. So this time it will be collide. So when we are comparing this time, this will be collide up to this point. Okay. So when we are comparing this one, this will be sent. Okay. So in the particular time, so these all 4 packets are transmitted, 4 frames are transmitted. So data collision may be occurred. Here also see this frames already sent. There is no collision because here no data, here no data, here no data. Only session 3 is sending, but when we are sending session 2 and 4, it may be collide. Okay, that's why they are given the shaded line so far showing collision durations. How Algo protocol is working? Okay. It will check if medium is free, it will transmit. That's all. Okay. So it will check start session has a frame to send. Here is number of times. Okay, how many times it is try to send the data without collision. Okay, first initially send the frames, wait timeout time. What is the timeout time? In Aloga protocol, we have to 2 times of propagation time. 2 times of propagation time. Okay, so TP means propagation time. So because we must be know it will reach the destination, and as well as we know that receiver is sending the acknowledgement. So one propagation time and the return acknowledgement. So 2 times of propagation time required for checking acknowledgement received or not. If acknowledgement received within the time, the packet is success. Otherwise, what it will be happen? So again, k value will be increased second attempt. Okay. So again, it will check k greater than k maximum. We have to fix k maximum equal to 15. Why? Because we will try 15 times. Otherwise, again, it will have to wait sometimes, or backup time it will check. So, okay, if more than 15 times means the process will be aborted. Otherwise, it will try with next second time. Okay, it will choose the random number of time. That time it will wait. Then after that, again, it will use the medium and transmit the data. Second method is slotted aloga. Aloga means there is no slot. So all the session will send the data at the same time. That's why collision may be occurred. Second one is a pure aloga method. This method. So what is the pure aloga? Pure aloga means previously we discussed, no? That is pure aloga. What is the vulnerable time? 2 into frame transmission time. TFR means transmission time of frames. This is so because there is no rule that define when the session can send. Okay. A session may send soon after another session has started, or soon before another session has finished. Okay. So we don't know when it is started, when it is transmit, or when it is over. So for that reason, slotted aloha was invented to improve the efficiency of pure aloha. Okay. What is the pure aloha? There is no time when the frame will be start and end. The session will send, it will reach or not, it will receive the acknowledgement or not. That's all. If received the acknowledgement, packet is transmitted. Sorry, frame is transmitted. Otherwise, frame will be lost. So again, it will resend it. Okay. How much time it will resend? 15 times. So in slotted aloha, we divide the time into slots of TFR. Okay. Timing for a transmission of frames. TFR. So this time, this frame will transmit. Session 1 will transmit in the particular time. Session 2 will transmit this time. So like that, the time will be allocated in the slotted aloha. So only the problem is force the session to send only at the beginning of the time slot. Whenever the time slot is allocated for the particular session, that beginning time only we are permitting the session to transmit the data. Okay. So here we'll see slots. They are given the slots: slot 1, slot 2, slot 3, slot 4, slot 5, slot 6. So the only condition is this slot for this session, this slot for this session, not like that. The only condition is when the slot time is start, the session will send the data. Okay. So first slot, no one sent. So the session 1 is transmitted. There is no collision. Okay. But second time, what happened? Session 2 also transmit the frame. Session 3 also transmit the frame. When the time starts, both the sessions are tried. So these frames are occurred in the collision. So same like that, the session 1 and session 4, the same slot it is forwarded. So it will be resent, but here there is no collision, here there is no collision, here there is no collision. In slot 2 and 3 have the collision. Okay, so then the particular session will resend the same frames. Okay. So next one is important method is carrier sense multiple access method. What is carrier sense multiple access? To minimize the chance of collision and therefore increase the performance of the transmission, the CSMA method was developed. The chance of collision can be reduced if the session sends the medium before trying to use it. Okay, so what is the meaning of that? This is the session. Okay, this session is connected here. Another session is connected here. Another session is connected here. Before transmitted, the session will check the medium. Medium is free or not. That is busy or not. Okay, so both it will check. If it is busy, it will do something. If it is not busy, it will transmit the data. Okay. So carrier sense multiple access requires that each session first listen to the medium before sending it. So sense before transmit, that concept it will use, or listen before talk. Before talking, we have to listen, then we have to talk. That same sentence we have to follow in the CSMA. Can reduce the possibility of the collision, but it cannot eliminate it. Okay. So since the medium, since the medium is busy or not, if it is ideal, it will transmit. If it is busy, it have to wait. So it is chance of reducing the collision, but it is not eliminating the collision. Stations are connected to share the channel. Okay, for what purpose it is sensing it? Sharing the channel. So even the possibility of collision still exists because of propagation delay. Okay, so propagation delay may be happen. When a session sends a frame, it still takes time for the first bit to reach every session and for every session to sense it. Okay, so medium is there. One session is connected here, another session is connected here, another session is connected here. Okay, so what happened? This system is sending the data. Okay, so data will reach here, no? Then only the system knows the medium is busy. Okay, still reaching this first bit, it's don't know the data transmitted by this session. Okay, session 1. So in case session 2 is there, session 2 when it knows the first bit is reached here, then only it knows medium is busy. So example, consider this is the third node. Okay, so first node is transmitted. So till reaching the first bit to up to this point, first bit reached, then only it knows medium is busy. Otherwise, what it will think? Medium is ideal. So again, it will start the transmission. This problem may be happen. Okay, space or time model of the pollution in CSMA. See here, session A, B, and C. So what happened here? So this is the time 1, this is the time 2, like that. CSMA will check what happened. This you see here, area where A signal exists. Yellow color signals are transmitted by node A. Blue colored signals are represented by B signals. Okay. So what happened while it is transmitting? These shaded lines. Okay. So this shaded lines is there, no? These lines are have both the signals. So it may be occurred collision in this area. Okay. So for avoiding those things, we need persistence method. What should a session do if the channel is busy? Okay. So persistent method we have some rules for when channel is busy, when channel is idle. Okay. So for that, we have 3 methods for answering those questions. So one persistent method. What is one persistent method? It's a simple and straightforward method. What is that? The session finds the line is idle, it sends the frame immediately. Okay, the probability is 1. That's why one persistent method. It will check this medium is free means it will start the transmission. That's all. If it is not busy, you have to wait some random amount of time. Okay. Here also collision will be occurred. Why? Because two or more sessions may find the line idle and send their frames immediately. Okay, so the medium is there. So session is connected here. So what happened? It will check medium is free. Here also free. Here also free. So what it will do? This session also ready to start the transmission. This is also start the transmission. This is also start the transmission. Finally, collision may be occur. Non-persistent method. Okay. So it is the second method. What it will do? So here line is ideal means it sent immediately. If the line is not ideal, what it will do? Will wait the random amount of time. Okay. The one persistent, there is no waiting time. It will check. Session is free, medium is free, it will transmit. Otherwise, it will wait. Okay. But here it will check. If it is not ideal, it will wait for random amount of time, then sensing the line again. Again, it will check when the medium is free. Okay. Here also the chance of collision is there. How? Unlikely. The two or more session will wait the same amount of time. So random amount of time it is waiting now. So if it is waiting the same amount of time, again it will retry at the same time. So simultaneously it will try now. So again collision may be occurred. So overcome those two problems, the P persistence came. What it will do? The P persistent method is if channel has time slots. Okay, the channel has time slots with a slot duration equal or greater than the maximum propagation time. Okay, so what happened? If one frame is there means it will have the slot duration is maximum of that propagation time. Okay, so it have to wait the particular frame will reach to the destination. Okay, after reaching the second slot will be allocated for another system. Okay, so combines the advantages of both the system which we are discussed earlier. So here how it is working. So the session sends its frame when the probability P is there means it will start the transmission and probability Q equal to 1 minus P. Okay. The session waits for beginning of the next time slot and check the lines again. Okay. So here time slot are also used, and if the line is free, then it will transmit. If line is busy, you have to wait the random amount of time. So here, in case if it is happened, backup procedure will be work. Simple diagrammatic representation. So one persistent method, what it will do, will check the channel. Channel is ideal means session can transmit. Channel is busy means again it will go and sense the medium. That's all. So here non-persistent method, what it will do? If it is ideal, it will session can transmit. But if it is busy, it will take some random amount of time, then it will wait. Okay. Then after the random amount of time, it will check the medium. Here what will be happen? So both the method will be there. Initially, channel will check. If it is ideal, it will transmit. Okay, it will check the probability. The probability value is less than or equal to means session can transmit. If it is greater than P, so it will take some slot and it will wait. So then it will check again it is busy or not. If it is busy, then backup procedure will be happen. If it is ideal, then it will transmit the data, then it will check the probability. Okay. Now this is the time for reflections part. We have 10 seconds time. You just answer the question. In the non-persistent method, transit the bit if session is ideal. It will wait the random time. Probability equal to 1 or probability equal to. What is answer? Okay, time over. So answer is both 1 and 2. It will transmit the bit if session ideal, as well as it will wait random amount of time. Okay. So in this video lecture, now having completed the discussion on Ethernet standards, now it should be able to identify the transmission time while using random access protocols. Okay. So now Identify the transmission time while using random access protocol. So this is small sum we just identified. Assume the propagation delay in the broadcast network is 12 microseconds and the frame transmission time is 8 microseconds. How long does it take for the first bit to reach the destination? How long does it take for the last bit to reach the destination after the first bit has arrived? Okay, so normally, propagation time will be propagation time, maybe how it will take uh, distance by speed. Okay, so distance by speed we will check. But here, what they are saying that propagation delay they are given already. So 12 microseconds. So the first bit, this is the sender, this is the receiver. So the first bit will reach, that is the propagation time. So what is the meaning of that? First question. Easily we can say the first bit will reach the destination with 12 microseconds. So the answer is 12 microseconds. No need to calculate the speed and length of the transmission medium. So how long does it takes for the last bit? Last bit means entire bit as well as frame transmission time is there, 8 microseconds. So total 12 microseconds for propagation. Frame transmission time is 8 microseconds. So what is the answer for here? 12 plus 8. So 20 microseconds. So that means initially propagation time and last bit will reach the destination at 20th microseconds. Okay, thank you. So for further readings, you just check the textbook, chapter 12.1 random access method, and also you can refer tutorial series. I hope you are enjoyed this video. I hope you are understanding the concept of multiple access methods. Thank you very much.